In this experiment, you'll investigate the relationships between the four variables that affect the behavior of gases: pressure, volume, number of moles of gas, and temperature. Now, to do that, you're going to use the LabQuest to measure the pressure of a gas using the gas pressure sensor. You'll have a setup that looks something like this, where you have the gas pressure sensor that will be connected to the LabQuest. In the first part, you'll have the syringe directly connected to the gas pressure sensor. With that syringe, it has some graduations on it, and it has a plunger that moves out and in. Now, that plunger measures the volume at the end closest to the point of the syringe, farther from the handle of it. Because when you push it in, that seal, there are three seals here, the seal that is closest to the pointed end will read 0. So if I want 10 milliliters in the syringe, I need to have this seal, the one closest to this end, on the 10 graduation mark. Now, bear in mind that that gas pressure sensor also has some volume of gas inside of it. In this case, that volume of gas is 0.7 milliliters. So, when you go to enter the volume, you need to enter the volume of the entire system, the syringe plus the gas pressure sensor. So, if I have the syringe at 10 milliliters, that means the volume of the system is 10.7 milliliters. In later portions of the experiment, you'll have the gas pressure sensor attached to a flask using some tubing. The volume of that tubing is 4.0 milliliters. Make sure, again, you account for the volume in the tubing and the volume in the gas pressure sensor. You'll then have a flask, an Erlenmeyer flask with a rubber stopper in it. You'll have some valves. Sometimes you'll need to have the valves open. Other times you'll need to have the valves closed. You will also have the syringe attached for some of the parts. Other times you won't need the syringe attached. But with that volume of the Erlenmeyer flask, note that it says 125 milliliters, and it's 125 milliliters plus or minus 5%, so it's not a particularly accurate volume measurement, to a line. But there's more space in there. Now, we don't necessarily want to measure the volume of the entire flask all the way up to the top because we have that stopper in there occupying some space. So you're going to want to measure the volume of that flask that you have with the rubber stopper in place. You don't, however, want to get any water into the tubing or into the gas pressure sensor. So remove the valves from the plastic fitting. As you go to reconnect the valve, it just needs to be finger tight. You don't need to really crank down on it or you'll break those plastic fittings and then you'll have a leak. Now in part 3, you're going to measure the volume as a function of the temperature, keeping the pressure and number of moles constant. You're going to have a setup that looks something like this, but you're going to have a water bath surrounding the flask. Now ideally, our syringe would be frictionless and would automatically adjust in or out, having that plunger move up or down in order to keep the pressure constant, equal to the atmospheric pressure outside the syringe. However, that syringe is nowhere near frictionless, and so you are going to have to manually push the syringe in or pull it out as the temperature changes. That means that you're going to need to keep a record of what the pressure is initially when you first start, and then adjust the syringe up or down over the course of that experiment.